Chapter 3 is about describing, exploring, and comparing data. So just a little review would be we're going to look at the center, variation, the distribution, which is also called the shape, any outliers and how they affect the data, and then changing characteristics of data over time. Descriptive statistics is whenever you summarize or describe the data. And then inferential is when you make inferences about the population or generalization or predictions. So you're making a prediction about the population. It's not always easy to find all the data for a certain population, so we use samples. And then we can use the sample data to make inferences or generalizations about the population. So 3.1 is all about the measures of center. We've learned about this before, not in this class, but you've learned about it in elementary, junior high, and high school. So measures of center. The center is a value at the center or middle of the data set, of a data set. So we've learned these as kids, mean, median, mode, right? Not range, because range measures the spread, but mean, median, and mode are all measures of the center. So mean, we all know how to find mean. Okay, so we know how to find the mean, which is used to be called average, which it still is called average. But when we talk about mean as statisticians, which is what we are when we're in this class, we only use mean. Do not use average. To find the mean, you add up all the data values and then divide by your number of addeds. Not going to write that down. We're pretty much further than that. All right, here's some notation that you're going to see quite a bit. We talked about this one already. This is summation. So if you see the little, it's just called a summation. You add up all of those values. X represents an individual data set. N represents the number of values in the sample. So that's your number of add-ins. Big N, uppercase, is your population values. And then this is called X bar, the mean of a set of sample values. We're going to call it X bar. So this is the sample mean. X bar equals sample mean. We're going to use notation instead of writing mean equals. And then this is called mu. It's a U with a line on front. So here's how I draw it. It's kind of like a cursive, right? Cursive U. So this is your population mean. And there could be a difference between these. That's what you'll compare. You're going to use the sample mean, but you might have the population mean that you can use as well. So example 1 is intervals in minutes between eruptions of the Old Faithful Geyser in Yellowstone National Park. All right, so we have some numbers, some data, and we are asked to find the mean. So how do we do this? Add them all up, divide by how many there are. So let's write how many there are. N is the number inside the sample. Yep. And then we're going to do the summation of X. Remember, X is your individual data values. So we're going to sum those. Do the summation. So go ahead and do that. $1,095. All right, that's what I got to. So to find your mean, which is called X bar, we're going to do the summation of X divided by how many are in the set, divided by N. So plug in the numbers. Mm-hmm. Okay. So the mean uses every data value, but this can be problematic if there's an outlier because it will affect the mean dramatically. Outliers affect the mean. We learned that in the crash course video. So what we need to know is if a statistic is resistant. Resistant means that the outlier doesn't affect it. So let's write a statistic is resistant if outliers, I'm going to put the S in parentheses, meaning one outlier or more than one outlier, do not cause a change, or much of a change, really. The term outlier is pretty broad. When we get further into statistics, we will use a formula to determine if a number is truly an outlier or not. But basically, it's just an extreme value that falls well outside the general pattern of most of the data. It may reveal important information, and it may strongly affect the value of the mean and standard deviation, and may distort the scale of the histogram. And it may be an actual recorded value or a typo, so you have to be careful of that. And guess what? Calculator tip. We can use our calculator to find the mean. Not just by adding them up and dividing. We can use stat, edit, put all the values in L1, and then do one variable statistics. This is pretty exciting. I sound excited, right? Okay, so let's go ahead and put these guys in. The eruptions. Okay, once you have them in L1, go to Stat, Calc now, arrow over, one variable statistics. We just have one variable. Enter, calculate, and check it out. It has that notation as well. So we've got to know our notation. So X bar is your mean. Summation of X is all of your values added together. Some of these others we're going to get later. N is how many we have, 12. Let's go. It says min X. What do you think that is? Minimum value. Q1. Do y'all remember anything about statistics with like box plot? No, it's called a box and whisker plot. We're going to get into that later. Oh, what do you think MED is?
The median.
The median, yeah. Q3, and then it has max. So we have lots of values, lots of information in here. So it's pretty cool. All right, so let's go ahead and do this next one. We can use L1 to find the mean. I'm not going to make you do it both ways. You know how to do it by adding them up, dividing. Now we're going to use our stat. So example 2. This is after the collapse of the two World Trade Center buildings. The following samples were obtained to measure the levels of lead in the air. So edit, go up to L1, clear it. And now put your numbers in. And how many do we have?
6.
Yeah, 6. So that's just something good to write down, just a note. So we put in L1, then go stat, calc, 1 bar stats. It says find the mean. Mean is X bar. And the way we are going to round is we are going to do one extra number than what was in the data. So this went to the hundredths place, so we're going to go to the thousandths place. So it'll be 1.538. Okay, now we have some questions. We need to look at the outlier and how it affects the information, the data of the mean. So outlier, what would be considered an outlier? Remove the outlier, then find the mean of the remaining values. So let's go back over to stat, go to edit, hit delete on 5.4 to make it, to remove it. Then do stat, calc, 1 var stats. And we got a different answer, right? Oh, I should put X bar. Hey, I messed up right there. So put X bar. So here with the outlier removed, we get 0.766. Was the mean strongly affected by the outlier?
Yes.
Yeah, it was. Yeah, I can show you. All right, let's go to the next page, median. Median is our middle value. Remember when we do our middle value, we are going to list them out and find the middle. Yep, ascending order. So notation is X tilde. So it has this little symbol here on top. To find the mean, first sort the data. Then if the number of values is odd, the median is the middle. The middle number. Because you'll have an even number on both sides and then that one in the middle. If the number of values is even, you have to take the mean of the middle two numbers. And we can also do this with our calculator. We can find the median there. It's actually easier to find the median if you just go through and mark them out. If they're already listed from least to greatest, you can just go through and mark them till you find the middle. Oh, hold on. Did I do that right? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. All right, it's in between 93 and 94, sorry. So then x tilde would be the mean of that, which is 93.5. Okay, then the next one. When we take out the outlier of 65, the median is 94. So what this shows us is that the median is not strongly influenced by outliers. And we found it earlier, the median is the one in the middle. All right, we're going to skip that example and keep on going. Let's talk about the mode. The mode is the most. The data value that occurs the most. A data set is bimodal when you have two modes. Multimodal means more than two modes. You can have a data set with no mode as well. So in this example, we can go through and find ones that are repeats. We don't have a symbol for mode either. No kind of notation. So our mode is 92 and 95 and 98. So it's multimodal. We don't look at mode very often, but it can be used whenever you just have categories, labels, and names, such as most common pets. It's not listed on the calculator either, but it does tell us some information here. We can put data into L1, press stat 2, and we can sort it out, and that'll put everything in least to greatest order. So that'll help us to decide if there's a mode or not. All right, let's keep on going. We're going to skip that. Let's talk about the mid-range. Mid-range is another way of measuring center. It is the value midway between the max and min values. So mid-range, we want to find midway between our max and our min. We don't worry about any other values, just your max and your min. So the formula is you add your max plus your min, and you divide by 2. So it only takes into account your max and min, nothing in between. Do you think this one's going to be affected by the outlier? Think about what an outlier is.
Yes.
Yeah, because it's a max or a min, so this one's going to be really affected by an outlier. So whenever we have this example, we're going to look at the minimum value, the maximum value. To find our mid-range, we're going to add those up and divide by 2. $81.5. Is that what y'all got? Okay. So that's halfway between the max and the min. All right, let's keep on going. We're going to skip example 2. Mid-range is rarely used because it's too sensitive to the max and min extremes. Benefits of it, it's easy to compute. It just tells you that there's multiple ways to find the center. But it's sometimes incorrectly used. So we don't really use that very much. The calculator does not give us that information, but it does give us maxes and mins, which we can use that to find our mid-range. Like I said earlier, with rounding, you're going to carry one more decimal place than the original set of data. Only round the final answer. So as you are coming up to the answer, do not round those values. Keep those the original. Okay, there's no single best measure of the center. It depends on the data set. Mean is used often, median occasionally, mode and mid-range rarely. The mean is relatively reliable, except for when there's your outlier. It takes every value into account. It doesn't make sense of calculations mean and median with data at the nominal level of measurement. So you wouldn't use centers with zip codes, ranks, surveys. So let's look at this example. The population of the mean of a population is not necessarily equal to the mean of the means found from different subsets. So we're going to look at this where they took the mean salary from each state. So 50 states, the mean salary from the states, and they found the mean of that. And they got 42,210. Do you think that would represent the mean salary of all secondary school teachers? That was a lot of means that I said, right? Kind of confusing. But what they did was they said, okay, Texas, here's the mean. New York, here's the mean salary. California, is it CA for California? Okay. Here's the mean. And then they found the mean of those. Would that be a way to represent the mean salary of all teachers? It really doesn't, because think of how many more teachers there are in different states. So it's taking into account that kind of like the weight of it. A small state, you're comparing it with Texas, even though we're a huge state. So not really. We would need the population mean, not the mean of the states. So population mean would be every single teacher salary. Okay, the last concept we are going to do on 3.1 is using a frequency distribution to find the mean. So remember, frequency distribution looked like this. We had classes, we had frequencies. So what we do to find the mean of a frequency distribution is we're going to pretend that all of these 44 are right in the middle. Are all the class midpoints, even though they're spread out among that whole class. So we are going to find the class midpoint, multiply the class midpoint by its frequency, and then add the products, and then basically find the mean there. Almost said that word, average. Don't say it. All right, so let's find the class midpoint. So it's midway between here. So halfway is right there. So you would add them up. So 0.2 plus 0.39 divide by 2, 295. Halfway between those be 495. We don't really care about those because they're 0. So that gives us no information. Halfway between here would be 1.295. So those are your class midpoints. So there's 44 of them because it's frequency. We're assuming or pretending that all of the rainfall was 0.095. So we're going to multiply these to get the total amount of rainfall. So 44 times 0.095. 4.18. Do the same thing for in between 0.2 and 0.39. And then times 1 is going to be 0.495. Times 1 here, 1.295. So we're going to find the summation of this column. The column is F times X, frequency times class midpoint. So add these up. $7.74. We're not rounding anything. We're just putting exactly what's there. So we're going to use this formula. Oh, we need to know the summation of F. Summation of F would be your N, like how many data values are there? How many are there? 52. So we're going to divide our total amount by how many data values we had. So we want to do one more than we had in our original set. So that'd be 0.149. So this is the average rainfall for Boston. Sunday rainfall amounts over 52 weeks. So this is our mean. Yeah, I said it again, didn't I? Average is a bad word. I gotta say mean. Yes. So our mean rainfall is 0.149. And this would be in inches. Okay, we are not going to talk about weighted mean. We're not going to do this example either. We're going to go to distribution. A distribution of data is symmetric. So this was actually talked about on crash course number 3. So whenever your data is symmetric, or this is a normal distribution, your mean, median, and mode are all in the center. When your data is normal, it's a normal distribution. So it's symmetric, same on both sides. They're all in the same spot. Whenever your data is skewed, though, skewed data means you have some outliers, you have a tail, you have some extreme values. So whenever we have a skewed to the left, your mode is still in the middle or highest point. And then your mean and your median, they're shifted to the left. Then if we have a right tail, we have a skewed right, our median and mean are shifted to the right. Think of the mean salaries. There was one that was talking about all these people who like knit something. I forgot what it was called. in one of the crash courses. And then it said Elon Musk showed up. What did that do to the mean? It skewed it. It made the mean be way up here when everyone all made about $19,000. But Elon Musk, his salary is just extreme. So that caused the mean to be skewed to the right. But it didn't represent anybody's salary because it was an outlier. So that is it for 3.1. So make sure you do the Pearson assignment.